Ed is a coworker of mine over at Hero Devs. He is a software engineering consultant specialized in complex migrations, Angular, and open source software. So we're glad to have you, Ed. I think this is your first talk.
Yeah, happy to be here, Chris. Thanks for having me. Great. So yeah, thank you, Chris. I'm really excited to get into this topic. It's something I've been working with the past couple of years pretty extensively. And kind of as I mentioned earlier, having worked as an attorney, I've had to take a lot of concepts from programming that maybe I didn't have a computer science 101 course on. And so this topic is about something that I find very useful, but has a lot of jargon. And I'm hoping to help translate some of that into a set of terms that might be more familiar to anybody who maybe isn't quite as familiar with them. So it's speaking the language of domain-driven design. We've already kind of gone over a lot of this, but just in case, my name is Ed Ezekiel, and I'm a solutions architect at Hero Devs. I think I mentioned it a couple times now, but I live in Memphis, Tennessee, and as we just talked about, I am a former attorney. So again, as I kind of said a moment ago, domain-driven design is, I think, a very valuable field, and I'll get into more of the details in a moment, but it has a lot of terms that I think aren't super obvious when you first come across them. Even the word domain itself, layered architecture, bounded context, I think they all sound great, and to me, they sound useful, but a lot of it wasn't necessarily created with a front-end repository in mind, with front-end architecture. So how do I take these concepts and pragmatically implement them in my project? That's kind of what I want to dive into. And how do I translate these terms into things like folders and NX tags and kind of things that we might be more familiar with, especially if you worked in an NX repo. This talk isn't limited to just people who use NX. If you use other monorepo tools like Lerna, that might work as well. But I'll use a lot of terms from NX to kind of tie to. Okay, so taking a little step back, why should I even care about domain-driven design? I'm going to offer two key reasons why I think it can be very helpful. The first one is that it can help decouple your teams and your applications so that you have kind of clearly defined places in your architecture where things go. This lets your teams work faster, you can work in parallel more easily, and hopefully even maintain projects later on because things are more decoupled. And kind of related to that, I think it helps answer the kind of age-old question, where do I put this file? This is something that it's such a simple question, but if there's not some kind of organization to the answer, it can cause even moderately complex projects to just spin out of control pretty quickly. So a relatively simple benefits, but ones that I think really can help a lot of different projects. And, just at another high level, does my project even need domain-driven design? So I'll kind of fully acknowledge that if your project is maybe just one application, maybe a smaller set of libraries, domain-driven design may not offer your project any real benefits for the amount of work it takes. But if you're in a large repository with lots of applications and libraries and very complex business rules, I think it really can help. And frequently I found, even if your project starts at a smaller scale, it can quickly grow, and hopefully the projects do grow. And so domain-driven design might be nice to have just from the start anyways. So as I've kind of mentioned earlier, I did not get a computer science 101 intro on domain-driven design. A lot of my experience trying to implement it has been, how do I actually use this in my project right now? So I'm going to offer a practical definition that isn't necessarily in the textbook, but I think it helps my mental model when I really try to figure out how to use it. So I'll suggest that domain-driven design can really just be boiled down to, an interface or type plus 3 categories of NX tags. And really, the rest of this talk is just walking through this definition. So taking each part of this and diving into exactly what that means for an example repository. Okay, so the first category of tag that we'll look at is the scope tag. This might be something you have seen if you've come across the NX reference documents. I think scope tag is one of the first ones they introduce to most people. And for the rest of this talk, we're going to look at a made-up company called Galaxy Money Corp. And we'll imagine that they have a couple applications, so a moderately complex set of applications. One of them will be called banking, and that's for day-to-day average users to access their bank information. And then an admin portal called staff portal. So already you can see there's kind of a dividing line within this system. You have a scope for banking and a scope for staff portals. And now we're going to start diving deeper and deeper until we have a fully fleshed out set of categories of tags that describe our scope here, our context. Just a quick example of what this might look like in your editor. So this is, again, probably familiar to most people who've worked in NX. You'll have an apps folder and a libs folder. And you have a banking app and a staff portal app. And so far, none of this is really that new. But you'll also notice there's a folder for banking and a folder for staff portal. So our domains begin to be expressed in the actual directory structure of our repository. So we'll dive deeper and deeper into each of these domains in the next few slides. Now, you'll also notice there's a shared folder. Domain-driven design doesn't necessarily discourage sharing code between domains, but there's a defined place now where that code lives. So if you have some UI widgets that just look the same everywhere, they can go here and be used across different domains. Okay, so now I think things start to get a little more interesting. So we're on the second category of NX tags here, and this is called the domain tag. And another way that you might have come across this before is a vertical slice. And I'll go into a little more about what that means in a moment. But here we're going to harken back to the kind of textbook definitions involved with domain-driven design and really just clearly show what that can mean for your project. So in kind of Eric Evans's canonical book on the topic, he defines a domain as every software program relates to some activity or interest of its user. That subject area to which the user applies the program is the domain of the software. So I think this is a fairly simple definition. I think it matches up with a lot of people's experiences. Usually some of the apps you've worked on probably have a few core parts that are the most important that relate to something your users are doing or interacting with. And domain-driven design is taking those models and putting them first in your design process. So how does that interact with scope? Well, you can see here there's a little vertical line in the staff portal scope between something called accounts and something called transactions. We're not going to dive too deeply into those particular domains, but you can just imagine that in the admin side of things, they deal with accounts and transactions pretty often. And so a large portion of that application can be broken up into accounts and transactions. And one benefit of domain-driven design is that there are now rules for if you're in accounts, what can import from transactions and vice versa. So it's not just kind of a theoretical idea that there are different parts of your application. You begin to structure it in a certain way and actually limit how these parts of your application can interact with each other. And going back to the directory structure, you can see here, so within the scope of banking, within the folder of banking, we have an accounts folder. And then the same thing under staff portal, we now have a folder for each domain. So again, the structure of your repository reflects the actual domains that your business cares about. You might also notice that there are two subfolders called accounts. And you might wonder, why? Why don't we just have one accounts folder? If a lot of apps use it, why would we, doesn't this violate dry? Aren't we duplicating all this material? Shouldn't we keep it as dry as possible? To me, this is actually a huge and crucial benefit of domain-driven design. On the banking side of things, they may have their own slightly varied, unique way that they understand what an account is. Maybe it's a very limited model that just has some, amounts and some brief presentational information. Whereas on the staff portal side of things, it can be something very different. It could be related to all other kinds of user information, and it could relate to transactions that maybe the banking app doesn't even know about. And so if you try to make your abstraction too flexible, it might wind up being leaky, and then you might wind up with, for example, components that suddenly are shared everywhere and useful nowhere and really difficult to nobody ever wants to touch them because now they're used throughout your whole application and there are 1,000 exceptions defined in the component. Okay, so now we're going to get to the third category, which is type tags. And another way to express this is horizontal slices. One quick note, I'll just give full credit to Manfred Steyer on this. A lot of what I'm presenting here derives from work he's done with domain-driven design and very literally images he's put together about vertical and horizontal slices. So thank you for that. But you can see here, there's literally a line between what you see as feature, UI, domain, util. And so within each domain, you can kind of see there are similar types of libraries that are repeated everywhere. And this is on purpose. I think in this example, but in general, I think we see that a lot of types of components and a lot of types of application code, we just repeat over and over and over again. So you have presentational components for one part of your app and another, and you have utils for one part and another and another. And this is a way to kind of formalize that structure. So there actually is a specific way to break up each part of your application by type. I'll just move on a little. So here, actually seeing a different way to understand this. Now we're kind of at the final level. So we have the banking scope, or the banking scope, and in the accounts domain, we have a data lib, a domain lib, a feature lib, and a UI lib. And then we also have the same exact thing for the staff portal scope. In the transactions domain, we have data, domain, feature, UI, util. And the NX, the type tags are actually also explained on the NX reference documents, but they fit very nicely within the idea of domain-driven design for a reason I'll talk about in a moment. So again, harkening back to Eric Evans's book on the subject, this relates to a concept called layered architecture, where you're dividing an application into layers, where each layer depends only on libraries in the same layer or on layers beneath it. So, very specifically, let's say you have a presentational component in your banking accounts UI lib. That can't import from data because the whole purpose is that it's kind of a dumb presentational component, and it shouldn't be able to interact with your data access features. So we've covered the three tags, and I think now we're going to get to basically putting all of it together in a key concept related to domain-driven design. So this to me is really the reason I made this talk, is struggling with the idea of a bounded context and what is that? What does it mean for your application? Why does it matter? So first, I'll just read the definition just to kind of establish a baseline, and then I'll go into it a little more. But the definition is that the scope of a particular model as a bounded part of a software system explicitly set boundaries in terms of team organization, usage within specific parts of the application, and physical manifestations, such as code bases in database schemas. So again, I think generally once I sit with this definition for a minute, I can kind of appreciate, oh yeah, I want context. I want, what I would say is effectively decoupled parts of my application. But what exactly, what is that? How do you actually implement that in application in a meaningful way? And maybe using some of the terms we looked at so far, how do we enforce the vertical and horizontal slices we've set up in our scopes, in our application? And that is, fortunately, a pretty trivial thing to do in an NX monorepo. You just define different types of tags and you set up your tag rules. So as you can see here, we have tags named scope shared, scope banking, scope staff portal, and then you have a different prefix. So you have domain transactions, domain accounts, and then finally type app, type feature. And taken together, I'm not going to go into every scenario here, but at the end of the day, it means your presentational component in your banking scope, in your accounts domain, can't import from any other presentational component somewhere from staff portal. It enforces all the rules that we're trying to achieve in our design. So practically, I would argue that a lot of domain-driven design boils down to just the tagging rules, just figuring them out and implementing them in your monorepo. And in practice, this defines your bounded context, because by definition, you can only use it within the scope of your rules, so that is your context. It can't be used anywhere else, so it's not. One quick note, and I know I'm running a little short on time, but 3 dimensions is enough to give you vertical and horizontal slices, but 4 dimensions might give you headaches. As NX has noted, every additional dimension of tags is exponentially more combinations of things. So unless you have a very, very strong use case, I would not reach for a 4th dimension unless you really need it. And a quick note just about brownfield projects and migrations. You might wonder, like, okay, great, this all sounds good for a new project, but why would I even begin to think about this for a set in stone brownfield project, or especially if I'm migrating something? And I'll suggest that there are still a lot of good use cases. And one particular example is you could, as much as you can carve out into domains, it's just low-hanging fruit to make your application a little more structured. So it's not an all or nothing proposition. If you have a ton of code and shared, at least you have some split out into domains, which should help clean your application up a bit. And I think that's about my time. So I'll say thank you.
Awesome. Thank you so much. That was great. So we have a couple questions for you from our audience. So Matt asked, how would you handle complex domains, for example, the ATM feature, which would need to combine accounts and transactions?
Yeah, so I mean, I hate this answer, but it really just depends. It's like if you have an account, like there's literally, if you have an interface of an account and the property of that interface is transactions, is your domain really just accounts, or can those be separate domains? What I'll say is you can allow a domain to import from another domain if you need to. So you might still find the benefit of breaking out your transactions into its own domain and saying that can only be imported into your accounts domain. So you still get the benefit of some encapsulation, but you're not trying to refactor your interface to fit some theoretical domain-driven design approach.
Thanks. We have one more question. Not sure who it came from. They asked, regarding not accessing things above it, what about model interfaces?
Yeah, so those tend to be basically the lowest on the totem pole of your layers, just because they are the foundation of everything in your app, more or less. So I usually I believe you let basically everything can import from domain usually. So if you have a utility to deal with kind of converting currencies, converting an account from one currency to another, like obviously you need the account domain into that utility, so you just let it import from the domain libraries.
Awesome. Thank you so much. We really appreciate having you on and giving a talk on this.
Thanks again, Chris.
Yeah. All right. I'll hand it off to Giovanni and Alex.
Thank you, Chris. So for our keynote speaker of the night, we have Alex Rickabaugh. So Alex is a senior software engineer at Google. He's a core team member of Angular and is working to optimize the Angular platform for the next generation of applications. Before joining the Angular team, Alex worked in the Google Sales organization, where he helped build the first large Angular application within Google. He is also has been a speaker at Google I/O, ng-conf, and he's an author at O'Reilly. And he's a sailor and a photographer. So welcome, Alex.
Thank you very much. Thanks for having me. Hello, everyone. I'm Alex from the Angular team, and I've been working pretty closely with Pavel and the rest of my teammates to kind of rethink reactivity in Angular. And we've told the story a bunch of different times, a bunch of different ways, kind of why we're doing this and what the benefits are. But this is my attempt to kind of put together that narrative as a case in point, as one specific example of, hey, here was something that was challenging to do in Angular, why it was challenging to do, and how kind of some of the new changes help. So the example that we're going to play around with is building a model-driven input. This is something similar to the ng-model directive, where we have an input that we can bind to some kind of model class and deal with its value and ask whether the input is valid and things like that. So we're going to start off by defining the model class. It has a value. We'll only work with strings for now. And it has a set of validators. So these are functions that can tell us whether or not they think the current value of the input is valid. So it has a valid status that we can read, which is a getter that just checks with all of the validators and makes sure all of them say that, yes, the current value is considered valid. And we have an API to kind of add additional validators to this thing. And so we expect to use it something like this, right? We'll create an input control in the template, and we want a directive in place that will synchronize this input control with an instance of this model class. So this is very similar to form control in reactive forms, and that's not a coincidence. Forms are actually a great way to kind of see some of the pain points and benefits that you get with signals. So here's our directive. It also fits on a slide, which is kind of nice. And we have our input for the model instance. And we have what I would describe as like a two-way binding to the native element, the input control. So we listen to the input event from the input element that we're sitting on. And when the user is typing into the input, that event is firing. And so we're synchronizing the value into the model at that point. And then during change detection in ng-do-check, we're going the opposite direction. We're synchronizing whatever value is in the model into the view. So if the user changes the value in the model, it updates the value that's displaying in the input control. So here's what that looks like kind of all put together in a component that's using it. So we have our value input with our model attached to it. And we have a simple kind of display that's showing the status, whether the model considers the input valid or invalid. And we're going to start off with just one validator that's going to make sure that you actually have typed something. So it'll reject empty values. And it works. So we have our input, and when we start typing in the input, we can see the status switch from invalid to valid. Hooray. What do you think happens if we swap the value input and the validation status? So we're reading the validation status first before the input control. Actually, it's a trick question. Nothing changes. Everything still works here. So even if the status is displayed first, you type in the input, everything's great. So let's make things just a little bit more complicated. Let's create a custom directive that will add a validator that rejects a set of characters that we consider to be illegal. So we'll call this the illegal directive. And this directive has another input, the set of illegal characters. And when it's initialized, it just adds a validator to the current model that it gets through injection that will check all of the characters in the current value and make sure that they are not in the set of illegal characters. And this works just fine. So when I type Alex, the status is valid. When I add the exclamation point, which was my illegal character, now the status has flipped to invalid. So far, so good. Let's take one more step and make our set of illegal characters dynamic. So let's make an input control for them, because it's always good to let users kind of define their own data validation. So here we have an input, we'll call it forbid, where the user can type in the set of characters that they think should be illegal, right? And we're going to pass that to the value of the input on the illegal directive. So this doesn't actually work. If you start typing in this input, like I added the exclamation point for forbidden, even though that's in my value, the validity status didn't actually change. And that's because of a quirk of Angular. It's not enough to just have a binding that's reading the value of a control. You actually need to make sure that change detection is going to run. And in this case, typing in this input doesn't trigger any events or any interaction in the browser that would cause Zone.js to say, hey, I need to run change detection. So we need to kind of trick Angular into doing that. And a common way to do this is to add an event listener that doesn't actually have a body. Like null is a kind of reasonable default there. And that's enough to trigger change detection whenever someone types in this forbidden character input. And now we see it working fine. So if I add the question mark character, if that's in my value, the status flips to invalid. But we still have two problems here. This design seems like it's working, but there's still a couple of issues. The first is it's kind of violating how Angular assumes data is going to flow through our templates, which is unidirectionally from top to bottom. And I'll show you how with the validity status, this just actually isn't the case and how that problem can manifest. So what happens if we move the validation status up to the top of the template instead of reading it below this forbidden characters? Well, it stops working, right? I type exclamation point, my value has an exclamation point in it, but somehow the status didn't update. And if you start seeing these things in an application, you get this like sinking feeling in your stomach, and you go look in the console, and sure enough, here's Angular yelling at me that, hey, expression changed after it's been checked, right? Why is that the case? What's going on here? So if we try to draw out what we think the data flow looks like, we have a text binding for the validity status. That's kind of the bubble at the bottom. And that's depending on the model.valid status. And the model.valid status is depending on the value, right? So far, so good. But there's actually a hidden dependency here, because the valid status is a getter that runs all of the validators. And one of the validators is reading the input of illegal characters on the illegal directive. And that makes our validity status sensitive to when this input is set. And sure enough, if you look at the template, you can see that we're kind of reading the validity status at the top. And then later on, that input gets set. So when the user types in a forbidden character, change detection runs, it runs this template. The model status is still valid, but then we set the illegal input, and that changes the result of what model.valid would have said. So we have changed this validity expression after it was checked. That's what Angular is complaining about. Can we fix this? Well, absolutely. We know how to fix expression change after checked, right? We put a set timeout. And this is a pretty big hammer. What we're doing here is creating an entirely new change detection cycle. And in that new change detection cycle, we're kind of assigning the illegal private set of characters that we're going to read in our validator. And we're kind of decoupling our execution from when that input actually gets set. And that's exactly what we should be doing in this situation. We need a new round of change detection because we're changing state that may already have been looked at in this round. So this is a one-line fix if you know which line to add this to. And tracking that line down can be quite complicated in a large application. Even with the set timeout, there's another problem that we can contend with if we try to use this component, this model-driven input, in a certain situation inside of an onPush component. So let's illustrate that by making a slightly fancier way to display our validity status. So we'll have a component that takes the model as an input and just displays the status there. So I'm just going to create a div with a CSS class that I toggle based on the validity status and display it in a nice fancy little circle. So green circle good, red circle bad. What happens when we make this validity display component, our nice little circle, an onPush component? It stops updating. And that makes sense if you know kind of the rules of onPush components. So onPush components, we know, get checked whenever an input binding to them changes. That didn't happen. Whenever an event listener inside of them fires, that didn't happen. And whenever someone calls change detector ref mark for check, right? That didn't happen. So the model.valid status in the template of this component is changing, but nothing is actually informing Angular that this component specifically needs to be checked. How do we fix that? One option is to turn to RxJS, right? Because the async pipe is particularly powerful here. It's going to call mark for check for us. So if we can express our validity status as an observable, then we can use the async pipe and kind of connect the reactivity there. But that takes some work. That takes some thinking because making the validity status observable requires us to make the value observable because we have to express the validity as a computation of the value. And that means our validators have to kind of work in observables instead of just plain values. And that set of validators really should be observable as well. Because we can add and remove validators, and that can change the validity status. And that means that our inputs suddenly have to become observable, and we need to use the async pipe everywhere we want to show this thing, which introduces a null type. It's a lot of considerations just to kind of connect the reactivity into an onPush component. And this is where signals really start to shine. So I won't go over the APIs because we've covered them quite a bit, I think, by this point. But let's go ahead and convert the model class to actually use them. So first, the actual value of the model will track as a signal. Then we can express validators as a computed, or the validity status, sorry, as a computed of the set of validators. The set of validators also becomes a signal because when we add a new validator, the validity status can change. The nice part is reading a signal subscribes that template to change notifications. So changes in this model.valid status will now mark this template as being dirty and we need to check it. So that solves the onPush problem. And now we have required inputs. Actually, this slide is a bit old. Now it's input.required, which is even cleaner. But yeah, we can make the set of illegal characters an input kind of quite naturally. And we can use that inside of our validator, just reading it as a signal. And notice we didn't have to convert the validator into some kind of like computed signal function. It's still a plain function that takes a string and returns a Boolean, but it happens to read this signal. So the nice thing is all of that dependency is tracked automatically. So just because our valid status is a computed, now it knows that it depends on this input signal. So that set timeout can actually go away now. Angular understands the signal graph. It understands that even though we've already checked that valid expression, it became dirty afterwards, and it needs to go back and revisit that a second time. So everything we've described here is kind of part of the v17 and the 17.1 story. So next I wanted to kind of look at where we are with signals and where we're going, what's coming in the future. So like 6 or 8 months ago, we presented a plan in an RFC, and the RFC kind of described a path from adding signals to Angular to this thing we called like signal components and signal change detection, and eventually being able to kind of get to a fully zoneless application, right? The value proposition was that if you were able to convert your application to use signals, to use signal components, then not only would you get faster change detection, but you would eventually be able to drop the zone.js dependency once all of your state and all of your components were on signals. And as we've kind of talked to application developers and started kind of planning out what this would look like in practice, we've realized there are some drawbacks with this plan that we really didn't like. First of all, zoneless was this kind of very difficult to achieve goal. It was possible only if everything in your application converted to signals, and that includes the libraries that you depend on, which made it very hard to kind of become a zoneless application at first, because none of the libraries in the ecosystem would be able to support it. And libraries wouldn't be pressured to support it because there were no applications that were using zoneless. So it created this catch-22. We also realized that it's kind of hard to adopt signals on a component-by-component basis. And that's because your components aren't often are not the owners of state. State sometimes lives in services. People have state management systems. So really, you have to convert the state to signals before the components can start converting. And in general, like the new types of signal inputs and signal queries were locked behind this barrier. They required a much bigger investment to actually start getting the benefit from. So we started kind of trying to figure out, can we make this more incremental? Is there a different story or a different roadmap that would get us to the same place, would give us the same, meet the requirements that we had set out for ourselves, but that was more accessible and that could deliver more of its value up front, incrementally, rather than one big payoff at the end? And so what I like about the kind of V2 of the plan here, this is what we've come up with, is that there's a lot more partying along the way. My little party emoji here, right? You get benefit as you start adopting these features, rather than having to wait till you get through the entire roadmap. So being able to use signal features in existing components. In 17.1, we shipped signal inputs. You can use them today. You don't have to convert to signal components. You don't have to convert all of your state to signals to start adopting signal inputs. And there's trade-offs here. There are not as many guardrails when you're doing this as there are with signal components. You can get it wrong. It's on push is kind of hard to work with in some ways, but it's a much lower barrier to entry. And we're currently actively working on building the zoneless experience for Angular on top of the existing APIs. So if you have an application that works with on-push, if your components are generally on-push, you will be able to use that application with zoneless without needing to migrate to signals. And that's really cool. You get a very nice benefit in terms of code size and sometimes performance for doing that. And then we'll bring signal components into the mix, which add the guardrails, right? Signal components are components that only update through signals. They make it very hard to mess up the data flow, and we're able to optimize them much more as a result. We can run change detection on much smaller pieces of the component because we know there's no other way that state could be changing. So we end up with like signal change detection. So one piece of the puzzle, one thing that was in the RFC that not a lot of people paid attention to, but it's one of my favorite features, is model inputs. Model inputs are kind of the two-way binding target equivalent of signals. So before, you used to write like an input and an output event that would have the name of like the input plus change, and you could two-way bind to that. Model inputs allow us to do that. But one of the ideas is we can enable two-way binding with this feature to directly to directives, or sorry, directly to DOM elements, directly to things like the input value property. So where we previously had to add that like fake event listener that would run change detection at the right time, now we can just directly bind to the input value, bind it into a signal, and then that drives the rest of our templates. So that's everything I have. Thank you very much for listening.
All right, awesome. Great talk, Alex.
Thank
So
you.
we have a couple of questions here from the audience. So you mentioned the input require instead of require true. Is that a new syntax in the latest or common version of Angular?
Yes, we shipped that last week in 17.1. We, like the RFC talked about required true. In actually implementing it, we discovered that that didn't actually work. That we couldn't get the right types in TypeScript plus behavior from our compiler to disambiguate certain circumstances. And so we iterated on the design and came up with input.required as a much cleaner approach.
All right. So Lance is asking, Alex, is this the same talk you gave at NG? I don't know how to pronounce it.
Yeah.
Glutevine, yeah.
Last year, yes. Yes, it is.
And then Matt is asking, would you think that signals will be added into reactive forms?
Ooh, that's a great question. Yes. The current plan is to explore how we can add signals to the existing form system without breaking the existing form system, without changing its behavior at all. One of the points of this talk is that like signals are actually a much better foundation on which to build a form system. So longer term, we do want to explore like what does a signal-like form system look like in Angular? Probably as some kind of evolution that also merges template and reactive forms in some way. That's been a long-standing kind of request from the community too, that we have these two form systems. Really, they're one under the hood that are largely, there's hotly contended debate of which one is better. Maybe we should just have one.
And in the same topic, Scott is asking, what is the roadmap for form groups and signals?
Yeah, so kind of the same answer. We want to make it compatible first, so you can use signals with forms, and then kind of smooth out the experience.
And last question, Akila is asking, something like signals component would that change how dependency injection work things are changing towards a more functional programming. Will it still be a class?
No, signal components will not change the kind of nature of components. They're not going to change the authoring, format. They're not going to change things like dependency injection. Signal components are just components that are actually optimized to work with signals. So there are components that kind of don't expect that you will change them through any other mechanism besides changing a signal. So today in components, you can call I can set whatever property I want in my template and then call mark for check. And that tells Angular like, hey, come and visit this because something might have changed. In signal components, the only way to do that is through setting a signal.